The clock strikes midnight. While most people sleep, a silent revolution takes place inside our bodies. Cells enter an alert state, initiating a fascinating process known as autophagy. This mechanism, discovered by Japanese biologist Yoshinori Ohsumi, earned him the Nobel Prize for Medicine in 2016, highlighting its fundamental importance for our health. Autophagy, a term derived from the Greek that means eating oneself, is a natural process of cellular recycling. During this phenomenon, our cells begin to digest damaged or unnecessary components, transforming them into energy and building blocks for new cellular structures. It's like a microscopic internal cleaning, essential to keep our body functioning efficiently. But what triggers this vital process? The answer may surprise you: the lack of food. Fasting, an ancient practice present in different cultures and religions, emerges as a powerful trigger for autophagy. When we deprive our body of nutrients for controlled periods, we activate a cascade of cellular events that go far beyond simple weight loss. Dr. Valter Longo, director of the Longevity Institute at the University of Southern California, has pioneered research into the benefits of fasting. Their studies reveal that periods of calorie restriction can not only stimulate autophagy, but also reduce chronic inflammation and improve mitochondrial function, crucial aspects for disease prevention and healthy aging. If you are finding this content valuable, please don't hesitate to show your support. Your interaction is essential so that we can continue sharing scientific knowledge in an accessible and engaging way. Together, we can unlock the mysteries of our body and promote a healthier life. Autophagy is not just a cellular cleaning process, it plays a crucial role in defending our body against various diseases, including cancer. Studies published in the Journal of Clinical Investigation suggest that autophagy may act as a tumor suppressor mechanism, eliminating damaged cells before they turn cancerous. However, it is important to highlight that the relationship between autophagy and cancer is complex. In some cases, cancer cells may use autophagy as a survival mechanism under stressful conditions. This duality highlights the need for more research to fully understand how to manipulate autophagy for the benefit of human health. Fasting, as mentioned in the video, can be a powerful tool for stimulating autophagy. However, it is crucial to approach this topic with caution. While the video presents fasting in a very positive light, it is essential to recognize that not all forms of fasting are suitable for all individuals. Dr. Mattson, a neuroscientist at the National Institute on Aging in the U.S., has extensively studied the effects of intermittent fasting on the brain. Their work, published in the journal Cell Metabolism, suggests that intermittent fasting can improve cognitive function and protect against neurodegenerative diseases. However, he also emphasizes the importance of adapting fasting regimens to individual needs. One of the most intriguing claims in the video is about the effect of fasting on cancer cells. In fact, research conducted by Valter Longo and his colleagues, published in the journal Science Translational Medicine, indicates that fasting cycles can make cancer cells more susceptible to chemotherapy while protecting healthy cells. This phenomenon, known as differential stress resistance, is a promising field in oncology. However, it is crucial to emphasize that fasting should not be seen as a miracle cure for cancer. It is a potential tool that should be studied further and always used under medical supervision, especially in cancer patients. The video also mentions the benefits of fasting for insulin sensitivity and weight loss. Studies published in the New England Journal of Medicine corroborate these claims, showing that intermittent fasting can improve glycemic control and promote weight loss. However, it is important to note that these benefits can vary significantly between individuals. One aspect that the video does not address in depth is the psychological impact of fasting. Research published in Frontiers in Psychology suggests that while fasting may have cognitive benefits, it can also lead to mood changes and increased stress in some people. This highlights the importance of a holistic approach when considering fasting practices. Another crucial point that deserves more attention is the ideal duration of fasting to stimulate autophagy. While the video mentions periods of 16 to 48 hours, recent studies, such as those published in Cell Research, suggest that the benefits of autophagy may begin to be seen after just 12 hours of fasting in some individuals. This indicates that less extreme regimes may be effective and potentially more sustainable in the long term. As we advance in our understanding of autophagy and fasting, it is essential to maintain a balanced perspective. While scientific evidence points to significant benefits, it also reveals the complexity of these biological processes. The future of research in this area promises to unlock even more secrets about how we can optimize our cellular health and, by extension, our longevity and quality of life. Delving deeper into the universe of autophagy, we come across a fascinating cellular mechanism that challenges our conventional understanding of nutrition and health. This process, far from being a simple cleaning, represents a sophisticated evolutionary survival strategy for our cells. Dr. Beth Levine, a pioneer in autophagy research, discovered that this process not only removes damaged cellular components but also plays a crucial role in immunity. Their studies, published in the journal Nature, revealed that autophagy helps fight bacterial and viral infections, acting as our body's first line of defense. While the video primarily focuses on the benefits of fasting for autophagy, it's important to note that there are other triggers for this process. Recent research, such as that led by Dr. David Rubenstein at the University of Cambridge, suggests that physical exercise can also stimulate autophagy, especially in skeletal muscle and the brain. This finding opens up new perspectives on how we can optimize our cellular health through a combination of strategies, not just relying on fasting. Integrating regular exercise with periods of calorie restriction may offer a more holistic and sustainable approach to stimulating autophagy. One fascinating aspect of autophagy that deserves more attention is its role in aging. Studies led by Dr. Frank Medeo, from the University of Graz, Austria, published in Nature Reviews Molecular Cell Biology, suggest that decreased autophagy efficiency is closely linked to the aging process. These findings raise an intriguing question: could we slow aging by stimulating autophagy? While this is an exciting prospect, it is crucial to maintain a realistic, evidence-based view. Aging is a complex process influenced by multiple factors, and autophagy is just one piece of this puzzle. Returning to the topic of cancer, it is important to deepen our understanding of how autophagy interacts with this disease. While the video presents an optimistic view of the role of autophagy in preventing cancer, the reality is more nuanced. Research led by Dr. Eileen White of Rutgers Cancer Institute of New Jersey, published in Genes and Development, shows that in some contexts, autophagy can actually promote the survival of cancer cells in hostile environments. This phenomenon is particularly observed in solid tumors, where cancer cells in the center of the tumor, deprived of nutrients and oxygen, can use autophagy as a survival mechanism. This duality of autophagy in cancer, sometimes suppressive, sometimes promoting, illustrates the complexity of biological processes and the need for personalized approaches in cancer treatment. We cannot simply assume that stimulating autophagy will be beneficial in all cases of cancer. Another crucial aspect that deserves attention is the impact of autophagy on the nervous system. Recent studies, such as those conducted by Dr. Ana Maria Cuervo at the Albert Einstein College of Medicine, suggest that autophagy plays a vital role in maintaining neuronal health and preventing neurodegenerative diseases. Their work, published in Nature Neuroscience, shows that decreased efficiency of autophagy in the brain is associated with conditions such as Alzheimer's and Parkinson's. This opens up new therapeutic possibilities, where stimulating autophagy could potentially slow or even prevent the development of these devastating diseases. However, it is important to note that the relationship between autophagy and brain health is complex. While adequate levels of autophagy are essential for neuronal function, excessive activation can lead to cell death. This delicate balance highlights the importance of a careful and personalized approach when considering autophagy-based interventions. One aspect that the video does not address is the role of autophagy in the stress response. Research led by Dr. Guido Kromer of the Cordeliers Research Center in Paris, published in Molecular Cell, demonstrates that autophagy is a crucial mechanism of cellular adaptation to various types of stress, including nutrient deprivation, oxidative stress, and damage to the DNA. This discovery has significant implications for our understanding of how the body deals with environmental and internal challenges. It suggests that practices that stimulate autophagy, such as intermittent fasting, may not only improve cellular health but also increase our overall resilience to stressors. As we advance in our exploration of autophagy, it becomes increasingly clear that this process is fundamental to our health and longevity. However, as with many aspects of biology, the key is balance. Stimulating autophagy through practices such as intermittent fasting can offer significant benefits, but must be approached with knowledge, caution and, ideally, under professional guidance. As we deepen our understanding of fasting and autophagy, it is crucial that we examine the molecular mechanisms underlying these processes. Dr. David Sabatini of the Whitehead Institute for Biomedical Research has been a pioneer in elucidating these mechanisms, particularly with regard to the mTOR, mechanistic target of rapamycin, pathway. Their studies, published in the journal Cell, reveal that inhibition of the mTOR pathway during fasting is a crucial trigger for autophagy. This discovery provides a molecular basis for understanding how fasting can promote cellular health, offering valuable insights into potential therapeutic interventions. However, it is important to note that prolonged inhibition of mTOR can have adverse effects, such as impairment of protein synthesis and cell growth. This highlights the importance of a delicate balance and the need for more research to determine ideal fasting regimens. The video briefly mentions the benefits of fasting for insulin sensitivity. Studies conducted by Dr. Satchidananda Panda from the Salk Institute for Biological Studies deepen this concept. Their research, published in Cell Metabolism, demonstrates that intermittent fasting can reprogram metabolism, significantly improving insulin sensitivity and glucose homeostasis. These findings have profound implications for the treatment and prevention of metabolic diseases like type 2 diabetes. However, it is crucial to recognize that the response to fasting can vary significantly between individuals, and that fasting regimens must be personalized and carefully monitored. One aspect that the video does not cover in depth is the impact of fasting on the intestinal microbiota. Recent research, such as that led by Dr. Aaron Ellenau of the Weizmann Institute of Science, suggests that intermittent fasting can significantly alter the composition and function of the gut microbiome. Their studies, published in Cell, indicate that these changes in the microbiota may contribute to many of the health benefits associated with fasting, including improved insulin sensitivity and reduced inflammation. This discovery opens up new perspectives on how fasting affects our health holistically. The video mentions the benefits of fasting for brain health, but does not fully explore the underlying mechanisms. Research led by Dr. Mark Mattson of the National Institute on Aging provides valuable insights in this area. Their studies, published in Aging Research Reviews, suggest that intermittent fasting may increase the production of brain-derived neurotrophic factor, BDNF, a protein crucial for neuroplasticity and cognitive health. This may explain the observed benefits of fasting on cognitive function and protection against neurodegenerative diseases. However, it is important to note that the effects of fasting on the brain may vary depending on age, health status, and other individual factors. More research is needed to determine optimal fasting regimens for optimizing brain health in different populations. One controversial aspect of fasting that deserves more attention is its impact on body composition and metabolism. While the video suggests that fasting can promote weight loss, the reality is more complex. Recent studies, such as those conducted by Dr. Krista Verity of the University of Illinois at Chicago, published in the Annual Review of Nutrition, indicates that intermittent fasting may be as effective as continuous calorie restriction for weight loss. However, they also show that fasting can lead to muscle loss if not combined with adequate protein intake and resistance exercise. This finding highlights the importance of a balanced approach to fasting, especially for individuals concerned about maintaining muscle mass. It also suggests that fasting regimes should be tailored to individual needs and goals. The video briefly mentions the role of fasting in longevity, but does not fully explore the scientific evidence in this area. Research conducted by Dr. Valter Longo, from the University of Southern California, has been fundamental in this field. Their studies in animal models, published in Cell Metabolism, suggest that fasting cycles or fasting-mimicking diets can significantly extend lifespan and reduce the incidence of age-related diseases. However, it is crucial to note that translating these results to humans is still ongoing and requires further long-term research. As we look deeper into the effects of fasting on the human body, it's crucial to address an aspect that the video only touches on superficially: hormonal impact. Dr. Jason Fung, a nephrologist and researcher specializing in intermittent fasting, has contributed significantly to our understanding in this area. Their studies, published in the Journal of Insulin Resistance, demonstrate that fasting can lead to dramatic changes in hormone levels, particularly insulin, growth hormone, GH, and insulin like growth factor 1, IGF-1. These hormonal changes can have profound implications for metabolism, body composition, and even cancer risk. However, it is important to note that the hormonal response to fasting can vary significantly between individuals. Factors such as age, gender, body composition, and health status can influence how the body responds to fasting. This highlights the need for a personalized approach when implementing fasting regimens. The video briefly mentions the anti-inflammatory benefits of fasting, but does not fully explore the underlying mechanisms. Research led by Dr. Miriam Merritt of the Icahn School of Medicine at Mount Sinai provides valuable insights in this area. Their studies, published in Cell, reveal that fasting can significantly reduce the levels of pro-inflammatory immune cells in the blood. This discovery has potential implications for the treatment of chronic inflammatory diseases, from rheumatoid arthritis to cardiovascular disease. However, it is crucial to recognize that inflammation also plays an important role in defending the body against pathogens. Therefore, excessive suppression of inflammation through prolonged fasting could theoretically compromise immunity. More research is needed to determine the ideal balance. One aspect that the video does not address is the impact of fasting on bone health. Recent studies, such as those conducted by Dr. Carlos Isals of Augusta University, suggest a complex relationship between fasting and bone metabolism. Their research, published in Aging Cell, indicates that while intermittent fasting may have overall metabolic benefits, it can also lead to loss of bone density if not implemented correctly. This highlights the importance of considering the effects of fasting on all body systems, not just the most commonly studied. The video mentions the benefits of fasting for cardiovascular health, but does not fully explore the underlying mechanisms. Dr. Benjamin Horn of the Intermountain Medical Center Heart Institute has conducted groundbreaking research in this area. Their studies, published in the European Heart Journal, suggest that intermittent fasting can improve several markers of cardiovascular health, including blood pressure, resting heart rate, and cholesterol levels. However, they also warn that individuals with certain heart conditions should approach fasting with caution and under medical supervision. One fascinating aspect of fasting that deserves more attention is its potential impact on cell regeneration. Dr. Valter Longo, mentioned previously, has been a pioneer in this area of research. Their studies in mice, published in Cell Stem Cell, suggest that cycles of fasting can promote stem cell regeneration in several organs, including the immune system. If these results are translated to humans, they could have significant implications for disease treatment and healthy aging. However, it is crucial to note that cell regeneration is a complex and finely regulated process. Excessively stimulating it through prolonged fasting could theoretically lead to unintended consequences, such as uncontrolled cell growth. This highlights the need for more research to determine optimal fasting regimens to safely and effectively promote cell regeneration. The video briefly mentions the impact of fasting on mental clarity, but does not fully explore the underlying neurobiological mechanisms. Research led by Dr. Mark Mattson of the National Institute on Aging provides valuable insights in this area. Their studies, published in Nature Reviews Neuroscience, suggest that intermittent fasting may increase neurogenesis, formation of new neurons, in the hippocampus, a brain region crucial for learning and memory. Additionally, fasting appears to promote the formation of new synapses, potentially improving brain plasticity and cognitive function. As we approach the end of our critical analysis of fasting and autophagy, it is crucial that we examine some aspects that the video does not adequately cover. One of them is the psychological impact of fasting, a topic that has gained increasing attention in the scientific community. Studies led by Dr. Emily Thurundler of Texas Tech University, published in the Journal of Nutrition Education and Behavior, suggest that intermittent fasting may have varying effects on mental health. While some individuals report improvements in mood and mental clarity, others experience increased irritability and anxiety, especially in the early stages of adapting to fasting. These findings highlight the importance of considering not only the physiological effects of fasting, but also its psychological impact. A holistic approach that takes into account both physical and mental health is crucial to maximizing the benefits and minimizing the potential risks of fasting. Another aspect that deserves more attention is the interaction between fasting and physical exercise. Dr. Krista Verdi of the University of Illinois at Chicago has conducted groundbreaking research in this area. Their studies, published in Obesity Reviews, indicate that combining intermittent fasting with regular exercise can enhance metabolic and body composition benefits. However, they also warn of the importance of properly synchronizing eating periods with training to avoid the loss of muscle mass and ensure optimal physical performance. It is important to note that the video presents fasting in a very positive light, but does not adequately address the contraindications and potential risks. Dr. Courtney Peterson of the University of Alabama at Birmingham has contributed significantly to our understanding in this area. Their research, published in the New England Journal of Medicine, highlights that intermittent fasting may not be suitable for certain groups, including children, pregnant women, frail elderly people, and individuals with a history of eating disorders. Additionally, people with diabetes or other conditions that affect glucose metabolism should approach fasting with extreme caution and under close medical supervision. One fascinating aspect that the video doesn't explore is the concept of fasting mimetics, compounds that can mimic some of the benefits of fasting without the need for actual calorie restriction. Dr. Valter Longo, mentioned previously, has been a pioneer in this area of research. Their studies, published in Cell Metabolism, suggest that certain dietary regimens or compounds, such as protein restriction or spermidine supplementation, may activate molecular pathways similar to those of fasting, potentially offering some of its benefits without the challenges associated with restriction. Prolonged feeding. However, it is crucial to emphasize that these fasting mimetics are still in the early stages of research, and their long-term efficacy and safety have yet to be established. They should not be seen as a substitute for a healthy, balanced diet. As we reflect on the content of the video and our critical analysis, it becomes clear that fasting and autophagy are complex and multifaceted topics. While the scientific evidence points to significant potential benefits, it also reveals important nuances and considerations that cannot be ignored. It's crucial to recognize that, like many aspects of health and nutrition, there is no one-size-fits-all approach that is right for everyone. What works well for one person may not be suitable or safe for another. Factors such as age, gender, health status, medical history, and even genetics can significantly influence how an individual responds to fasting. Additionally, it's important to approach fasting with a balanced and realistic mindset. While it may offer health benefits, it should not be viewed as a panacea or a quick fix for complex health problems. Fasting is most effective when integrated into an overall healthy lifestyle, which includes a nutritious diet, regular exercise, adequate sleep, and stress management. As research in this field continues to evolve, it is likely that our understanding of the mechanisms and applications of fasting and autophagy will become even more refined. This could lead to more personalized and effective approaches to incorporating these principles into health promotion and disease treatment strategies. In conclusion, while the video provides a valuable introduction to the concepts of fasting and autophagy, it is crucial that viewers seek additional information from reliable sources and consult healthcare professionals before implementing any fasting regimen. With an informed, careful, and personalized approach, fasting can be a powerful tool for improving health and well-being, but it should always be practiced with knowledge, respect for individual limits, and appropriate supervision.